Okay, shall I start? Okay, good morning, everyone. Thank you for coming on a Saturday, a winter Saturday, and waking up and coming up today. So thanks a lot. So this is my first time hosting a meetup. So if something goes wrong, I'm sorry. And a big thank you to Atyantik for helping me hosting this event. So today we will be talking about XRP ledger and blockchains mostly. So yeah, let's start. So before that, a bit about me, right? I'm mainly a backend developer. If we include AI, then I'm a full stack developer. And I started with Python, but now, as all the new developers, I'm into JavaScript. Okay, so yeah, and blockchain developer as well. Personally, I'm a nerd kind of guy, and I'm curious about everything. And of course, as a developer, I'm introvert. Now, today's agenda. So the first is, what is blockchain? Before we deep dive into XRP ledger, we should know what is actually a blockchain, right? We should know the fundamentals. Then finally, what is XRP ledger? Why the XRP ledger? Why should you use it? Why a blockchain, right? And then we'll do some hands-on session, right? So I hope everyone has brought their laptops and we'll be coding directly on the XRP ledger. And then questions and use cases, discussions, queries, etc. So before we start, how many of you know or have any idea what a blockchain is? Anyone? Like in layman's term, whatever you know. No? Yes.
Little bit about blockchain, like a linked list kind of structure.
Sophisticated linked list.
Sophisticated linked list. It's making sure that no data is changed over there.
Yes. Okay, so yes. And throughout my session, I will be asking lots of questions. Why? We will get to know, okay, and then in presentation, why I'll be asking questions. It is related to blockchain. Okay, that's why. Okay. So yes, as Sir said, some might just call it a sophisticated linked list. Okay, so blockchain in basic terms, it is a distributed ledger technology. Now, distributed in the sense it is not centralized to one entity or a company. Okay, it is distributed among users or among different entities. So let's say, for example, if you keep your money in a particular bank, okay, and if the bank goes down, then, well, you know, your money also goes down. RBI only insures some of it. In a blockchain, the blockchain cannot go down. Like if it goes down, you can just fire up your own server and it will be back. So that is the high level overview of a distributed ledger technology, that it's decentralized. Anyone can participate in the network. And what is a ledger? Okay, now what is a public ledger? I will need volunteers. I'm going to give a practical example now. So I need 4 volunteers. Who is ready to come up on stage? Need 4 people. Atif? Yes, yes, yes. Okay, good. Okay. 2 on the stage, 2 below. Okay. Okay. Now, a ledger is basically a public record of transactions between entities, right? So, what is your good name?
Mitesh.
Mitesh. Okay. So let's say we have four entities. We have Mitesh. Okay. No, screen. Okay. Yeah. Okay. We have Mitesh. We have Shivam. Okay. We have Harshal, and we have Hardeep. Okay. HA. Let's do HA. Okay. So we have yes. And so oh, okay. You go down side Hardeep. No. Okay. Yeah.
Don't worry.
So now let's say these four entities want to transact within themselves, like उनको पैसे का लेन देन करना है. Okay, for example, so let's say Mitesh, he gives 100 rupees to Hardeep and he records the transactions here on the ledger. Let's say this is a book, right? So let's say he gave 100 rupees to Hardeep. Yes. UPI. Okay, so he will write it here that Mitesh, okay, um, yes. Okay, so Mitesh gave Hardeep 100. Okay. In other words, we can say Hardeep owes Mitesh 100, right? Now, so this means Hardeep has to give Mitesh 100 afterwards, but we'll come back to it. Now, let's go to Harshal and Shivam, for example. So let's say Harshal gives Shivam 50 rupees, right? So Shivam, okay, so Harshal owes 50. Okay. Now, let's say Hardeep has enough money and he wants to repay. So we will not erase the past transactions. They will be there forever. Okay. We will just have a new entry where we say HA repays Mitesh 100, right? Now, who is recording those transactions? So anyone in the network can. So let's say if Hardeep gave Mitesh 100, he can just come here and then write it. Okay. So that's called kind of like a public network, public ledger. Now, what is the one fundamental flaw in this system?
Everyone comes from central point.
Exactly. So anyone can just come and make a new entry. So Harshil can just come and he's like, Mitesh owes me 1,000 rupees, even if he does not, but he can write it because he has the access, right? So that is the one fatal flaw of a public ledger. How do we tackle it? How do we counter tackle it? Any ideas? Like, how can we mitigate this issue? Yes, that's a good idea. Everyone has their own ledger. Anything else on top of it?
Kind of authentication.
Kind of authentication? Any proof?
You can say
Yes, different kinds of blockchains. Yes.
Keep notifying the other person.
Yes. Now, how XRP Ledger handles it is simple. Let's say Hardeep says, Hardeep gives Mitesh 100 rupees, for example. Okay. Everybody in the network sees it and agrees to it that yes, Hardeep did give Mitesh 100 rupees. And then only when everyone agrees, then the transaction is recorded on the public ledger. So that's how XRP Ledger handles transactions. Okay. Everybody who is in the network participating, okay, there it's called a consensus algorithm that everybody has to agree. It's around 80%. So if 80% people agree to a transaction, okay, if the transaction is validated, then it goes into the network, right? Now, okay, thank you. That's all. Thanks a lot. So this is, for example, this is one block of transactions, right? A blockchain is made up of multiple of those. For example, so this is, for example, one block. We can copy it and have another block. It will have different transactions, and each block has a unique number or a hash. Okay, so for example, we have ABC. This will be DEF, but the second block will have a link to its previous block, right? That's why you can say it's kind of a sophisticated linked list. So it will have a field called previous block as ABC, right? And yeah, so that's basically how a blockchain is. We have blocks of transactions which are connected. A good example is livenet.exapl.org. This is the whole map of the real-time transactions on the XRP ledger. That gives a really good visualization of it. If it loads, or else we'll come back to it later then. Okay, so it is a decentralized system. It is immutable. Okay, once a transaction is put on the network, it cannot be changed. Okay, it uses cryptography. Yes, it uses asymmetrical cryptography, public key, private key concept. Okay, so it is faster. A transaction takes around 3 to 5 seconds. So right, if I send someone money, it will reach his account in like 4 seconds at max. And then there is no priority. It's not like, okay, let's say I give higher fees, then my transaction will go faster. No, it's not like that. Every transaction has the same priority. Now history of the XRP ledger. So there were 3 people who originally founded it. Jed McCaleb, it's his image. Arthur Brito, nobody has his validated image because he has always been low, and like he has not come out with his face, so nobody knows what he actually looks like. Then we have David Schwartz. So these are the 3 people who launched the XRP ledger back in 2012. Okay, and they founded OpenCoin afterwards. Then they rebranded to Ripple Labs. Okay, Ripple is a big company in America if anyone knows about it. And yeah, then Ripple donated the XRP to a non-profit organization called Ripple Foundation, which handles the XRP Ledger ecosystem. Like there is grants, there are different programs, there are different meetups, etc. Jed McCaleb actually branched out. He created his own blockchain called Stellar. So, but David Schwartz is still the CTO of Ripple, so he's still working with the blockchain. Um, yeah, so these are some of the points. Like consensus protocol, the XRP Ledger uses unique federated consensus algorithm. Keep in mind, different blockchains use different types of algorithms. Okay, it's XRP Ledger which uses consensus, but there are different, like Ethereum, it uses proof of stake. Yeah, it uses proof of stake now, right? Yeah, Bitcoin uses different technology and etc. Decentralized DEX. Okay, now what is a DEX? How many of you have ever invested in stock market or know how the stock market works? Right? So basically, you know that there is an order book, right? Where you can place orders, buy, sell. XRP Ledger has an order book system since it came out in 2012. So you can trade different coins, currencies decentrally. And this is the first ever decentralized exchange ever to be introduced, right? So it is lightning fast. Again, you place an order on the exchange in 3 seconds, it will be executed. If your order matches, you will get the currency, right? Fast and secure settlements, scalability. Currently, it handles around 1,500 transactions per second. Uh, Not a lot, but currently it has only 200 or 100 transactions per second. Yeah, 89 transactions per second. So yeah, this is the live visualization. These are different blocks. These are different kinds of transactions in a block, for example. So yeah, and these are the validators, the network participants who validate if a transaction is good or not. Okay, so yes.
Yeah, and 2 questions. First is like, so consensus protocol, and there is a proof of stake protocol.
Mhm.
And similarly, Bitcoin might be using. So right now, let's say if we base on the technology to use XRP or whatever. So right now, what is happening with Bitcoin is that if we use Bitcoin, like it takes a huge amount of gas space if we want to validate where it is.
Yes. Yes.
So can this happen with XRP as
No.
well? And if there's
XRP ledger takes less than 1 cent in fee. Okay, so there is virtually no fee. Okay, and if you operate a validator, like for example, if you mine Bitcoin, you cannot mine XRP, right? All the fees are burned, so there is no incentive to run a server. That's why there are not a lot of validators who validate transactions. There are only around 150 or 200. Okay, so that's because you don't get any incentive to run a validator on XRP ledger. So yeah, the fees are not an issue. They will always be less than 1 cent. Okay, so yeah, they can never increase. For example, other networks fees increase if there is a lot of traffic. No, that does not happen on XRP ledger. There is one security feature where if an account is sending a lot of malicious transactions, then it will increase the fees for that particular account, but not the global fees. So yeah.
and this is because of the consensus protocol.
Yes, yes.
Um,
Yeah, the other
the
algorithms.
same thing is happening with Ethereum as well. Like if you are running on a level chain, then
Yeah.
that is costing the ratio of like a huge
Gas fees. Yeah.
gas fees as well. I mean,
Time. Yes, the other thing. No, on XRP ledger, it's 3 to 5 seconds. It's super fast.
it crosses around 1500.
That it has not, but if it does, then the blockchain might halt. Okay, it might, nobody knows. And even if it halts, then also your funds are safe because all it needs is a restart. Okay, it has halted in the past as well, but no funds have been lost because if it's halted, then you cannot move your funds. But as soon as it is back up, then yeah, we'll go into the code as well. The whole blockchain is open source. Okay, it is written in C++. We will head over to the code as well. Now, why the XRP ledger? It is easy to interact. How easy? We will see in our hands-on session. It is as easy as interacting with another API, right? So it's really easy. Low fees, atomicity. Yeah, transactions either execute completely or not. Like decentralized and the first ever decentralized DEX. Uh, let's take a look at the Ripple D. So Ripple D, it's basically Ripple daemon. This is the whole blockchain. You can literally clone it in your laptop and you can run it. So yeah, you're literally running the blockchain in your computer. Um, you need, recommended is 16 gigabytes of RAM, but you can run it in 8 gigabytes as well. So you need 16 gigabytes. For a good production grade server, you need like 32 to 64 gigabytes of RAM. So it is, so if you are making a product on XRP Ledger, you can run your own instance, you can get unlimited access to the blockchain, and it's not like it's going to cost you a lot, right? On other chains, the hardware requirements are actually sometimes a bit high to run your own server, right? So yeah, this is the whole code base of the blockchain. So it is open source. You can literally go, and if you want to change, you can propose a change. Okay, and if all the maintainers think that the change is good, it is needed, then it will be merged to the code base. But here's the thing, it's a decentralized system. Even if, let's say, Hardeep wants a feature, okay, on the XRP ledger, he coded it, he pushed a PR, the PR got merged to the code base, but every validator, okay, they will have to vote on the feature, that do we need the feature, right? um, So let's say there are, in our main example, there were 4 people, okay, who are the validators. Let's say if they think that the feature is useful, then they will say yes. We need 80% of the validators, 80% of the network to say yes to a feature. Then and then only it will be voted in. Okay, for example, this is a list of all the changes which were proposed. Okay, um, and you can see the status that is it enabled, and these, for example, are no. Okay, why? Because they're still in the voting phase. The community, the validators are deciding, do we need those features, yes or no? Now these green ones, these are the features which are voted yes, that yes, these are the features which will be integrated in the blockchain. After a feature is said yes, there is a cooldown of 15 days. Okay, so if there are any bugs or anything, then they can be found in those 15 days. After 15 days, the feature will get merged in the blockchain, and yeah, you will have the feature ready to use, right? No, this is not. Thank you. A real good website is xrpl.org. It will give you everything about the blockchain, the concepts, the tutorials, guides, and everything. Here it has really good diagrams and everything as well. So make sure to go over to xrpl.org. And this is a block explorer. A block explorer basically is used to know more about the transactions on the blockchain, what is going on. Okay, look at the metadata and everything. For example, we can click on the validators. It will show us all the validators who are there in the network, right? We can say 195 validators. Now there are two kinds of servers. There is a validator, there is a node. Okay, a validator validates a transaction. Okay, as we saw on the code here, the blockchain code, it has an algorithm built in which validates if a transaction is correct or incorrect. So it's not like you manually have to code anything, right? The blockchain software takes care of it. You just have to run a validator and it validates the transactions. So out of 195, now here comes the second twist. How many of you have watched Silicon Valley? Right. Do you know about the 51% attack? Yes. So let's say I can just run 400 more validators and I can take over the whole blockchain, right? So in order to mitigate that issue, there is a thing called UNL, a unique node list. So even if there are 195 validators, there are only a few validators who are like the boss, right? Like who control the network. And you see the stars, these are the validators who are the main validators. So if we see there are 35 main validators, if 80% out of those 35 say a transaction is correct, then and then only it will be put on the blockchain. If 80% of them vote for a feature, okay, for an amendment, a feature is known as an amendment. So if 80% of those 35 validators say yes to a feature, then and then only it will be merged. Now you might ask, then what's the use of running all those different validators, right? Like they don't control anything. Technically, yeah, there is not a lot of advantages of running a validator if you're not in the UNL. But if you want to get into a UNL, you have to run a validator for 1 year. You have to maintain it. Okay. So, and then you can participate in the voting and everything. Even the fees, for example, the fees are also voted by the UNL people. So they control how much fees should be there on the XRP ledger. They control the whole aspect of it, right? So that is the UNL. And even if there are only 35 UNL, there are more than 200 validators which are non-UNL. They are just validating transactions. They are not doing anything, but still they are running. And then we come to the second type of server, which are nodes. Now you might see there are 980 nodes. Nodes are like the smaller brother of a validator. They don't say yes or no to a transaction. If a transaction is validated, they just simply fetch it, they keep it in their database. Okay, so that is a node. Now, why are nodes useful? Because they are used everywhere on the blockchain. Let's say if you query something like what is my balance, for example, on the blockchain, I will probably connect to a node. It stores the data, so it will give me that, hey, Adi, this is your balance, right? So they are used to store the data. And if a validator if I want to run a validator, it is advised that I run one or two nodes as well, which are connected to the validator, so that the validator has a constant stream of transactions going to it, right? Um, yeah, so that's about nodes and validators. Now, what are the use cases, right? If we talk about, yeah, it's a blockchain. I get it. It's fast. It has low fees, but then where do I use it? We talked about the DEX part. So like stock market. Um, so let's say I select a coin, for example, the solo coin. Okay. You can issue a new currency on the XRP ledger. It's kind of like, you can say, a stock, right? In stock market terms, this is, for example, a stock. You can see its chart, right? And you can trade it. So you can literally right now place an order. It will be executed in 3 seconds. And yeah, if you have a matching order, you will get the currency. Now there are different kinds of wallets. There is a gem wallet. There is a Summon wallet on mobile. So let's say there is this coin called XPM, and you can see my balance. I have 1000 of it. Okay. And I have something around 7 XRP in my wallet. Now let's say I want to buy some XPM. I'll just say I want to buy 1 XRP worth of XPM. It will calculate it. I will do swap. It will make me sign a transaction, submit. And my balance on XRP went from 7 to 6. And my XPM balance also updated, but it's not reflecting here. But yeah, you get the gist, right? That's how that it's like that easy to just trade currencies, right? And this is fully decentralized. It's not like some middle entity, like on stock market we have NSDL and NSE, BSC controlling all the order books. This is a decentralized order book. Now the next feature it has is AMM, automated market makers. Now, the main problem with order books is liquidity. Let's say I want to buy a currency, right? But there are not enough sellers. There are not enough people who are willing to sell me a particular currency. That's where AMM pools come in, right? Let's say Hardeep has a lot of XPM, okay? And he does not want to sell it, right? But he's like, okay, what if I मैं कुछ करूँ जिससे I get fee, like I get money for just holding the XPM, right? And I don't have to sell my XPM. Okay. So that's where liquidity pools come in. So there are, let's say, two buckets. One is XRP and one is XPM. So Hardeep has a lot of XPM, and let's say I have a lot of XRP. So I will deposit my XRP in this pool, in this bucket, and Hardeep will deposit his XPM in this bucket. Okay. Now, let's say some other person, Mitesh, for example, wants to convert his XPM. He wants to sell his XPM and get XRP for it. Let's say he goes to the order book first, but there is not enough people who are selling, who are willing to buy XPM for XRP, right? So yeah, what does he do? Mitesh, what does he do? He has no options, like, hey, the order book is empty. So in that case, he goes to an AMM pool. What he does is he just there is a bot. Okay, there is an automated bot in between who controls both of this bucket. He tells the bot that, hey, I am willing to give you XPM, okay, but you have to take some XRP out of the bucket and give it to me. And this bot is smart. It automatically gets the best rate in the market because it is connected to the order book as well, right? So even if the order book is good enough, if it's not empty, okay, then also it will go to the order book, it will run the best trades, okay, and based on that price it will give Mitesh XRP and take XPM. Now what happens is then there will be more XPM in the pool and less of XRP, right? So yeah, this will be the pool after Mitesh executes a transaction. So now, of course, this affects the price. Okay, if the currency is more in a pool and the other currency is less, then the price goes down because he just sold, right? And it's the other way around. If someone buys a lot of XPM, then the price goes up. Now, XRP Ledger AMM is smart. Okay, it automatically rebalances the pool. So if there is a lot of XPM and a less of XRP compared to the order book, okay, compared to the order book, so then what it will do, it will automatically take this XPM out. It will sell on the order book automatically, and then it will deposit the XRP back in the pool, and it will match its price to the order book's price, right? So uh, in other EVM chains, for example, Ethereum and other protocols, sometimes pools do get imbalanced, okay, because they might not have that functionality in them, right? But no, here the pools are smart. They automatically rebalance themselves. Now, the other thing, while we are talking about Ethereum and stuff, they all have smart contracts, but XRP Ledger, it does not have any smart contract. It is fully native, right? So everything you do is on chain, okay. You might have heard people saying that I connected my wallet, Ethereum wallet, to a website and all my Ethereum got drained out. That can never happen to you on the XRP Ledger. You can connect your wallet to 1,000 sites, okay, but they can never access your XRP. Only you can control it, unless and until you are dumb enough to say yes and approve a transaction going to them. Other than that, they cannot hack your wallet because there are no smart contracts, right? On Ethereum and other EVM compatible chains, you can have smart contracts which give access to your wallet and different stuff, right? So that's one of the other things. XRP Ledger is really secure. It's really easy. Okay. Now, um, let's go to the hands-on session. Okay. Other question? Huh? Yes.
The part, is it on a chain or?
It is native. It is on the chain. Yes, it's like a feature. So it was actually coded by David Schwartz. It got introduced last year only. So he coded the feature. It got merged, and then people voted on it. And there's actually a really fun story. When it was voted and when it was in the 15-day cooldown, they found a critical bug, and the validators again voted no. So it was not merged, and then they pushed a fix, and then it was merged. So yeah, it is on chain. There is no smart contract stuff. It happens in the code.
Because like you mentioned that there is no smart applicant that is on.
Yeah, but that's the beauty of it. There are no smart contracts. Like everything happens on chain. Yeah, there are NFTs. Yes, there are NFTs. JPEGs. There are NFTs. There are fungible coins. Okay, there are AMMs. There are payment channels. Yeah, a really good concept. What are payment channels, right? Let's say Herschel, for example, has a business. Okay, and he has to bill me every month or every week. Yeah, let's say every week for 4 weeks. Let's say he has to bill me 10 XRP every week. Okay. Now, instead of me sending a payment every time, I want to set up something automatic, right? So what I do is I allocate 40 XRP. There are 4 weeks in a month. I have to pay him for a month, 10 XRP every week. I make a channel between my address and his address that, hey, I allow him to withdraw 40 XRP from my account. Okay. Not at once, okay, but at particular intervals. So every week he can withdraw directly. I don't have to do anything. He can have his software which automatically takes 10 XRP from my wallet and deposits to his wallet, right? So that is a payment channel. It yeah, there are also checks. So like we have checks in everyday life. You can I can, for example, give a check to anyone, and then whenever they want they can cash it. And yeah, so now checks support all kinds of transactions. Like I can give a check for an NFT, right? That, hey, I will transfer this NFT at whenever this guy checks in the cash, and yeah, it can happen. So checks support all kinds of transactions. That's another beauty of being on chain. Like if you implement a feature, it works everywhere with everything. There are checks, there are payment channels. There are escrows. Another really cool feature is an escrow. What is an escrow? Um, let's say I am buying a house, for example. Okay, this is the house I want to buy. This house is worth something around 100 XRP. Okay, there will be a realtor in between, a broker. Okay, he will finalize the deal, right? Generally, what happens is once the deal is finalized, he will ask me to escrow a particular amount. Okay, not the full price, some amount. Let's say 50 XRP, right? So there is this escrow. So I will deposit 50 XRP. What is an escrow? It is kind of like a container, okay, where you deposit your money, and it will be locked in there unless and until a certain situation is met or a certain time is met. So let's say I deposit my XRP in this escrow, and my condition is that it should be unlocked after a particular date. Okay. So after a particular date, 50 XRP will automatically go into the owner's account or the realtor or brokers, whatever, whoever's account I have put in as the destination. Okay. Now there are also conditional based escrows. You can configure it, look into it. So yeah, that's also another really good feature. There are cross currency payments. Yes, another really cool feature. Okay, now let's say there are two currencies, GBP and BRL. Okay, I want to exchange, I have GBP and I want to exchange it for BRL. Now what happens in an ideal scenario is there are good order books for direct XRP pairs. For example, there will be a lot of orders for GBP XRP, there will be a lot of orders for BRL XRP, but there might not be a lot of orders for GBP and BRL because people generally want the native currency like XRP. Right? For example, in stock market, you buy and sell stocks with INR. You don't, for example, give one stock and get another stock, right? So that is not an ideal kind of pair. So that's why on XRP ledger it is possible to have a pair like that, but there is no liquidity at all on these pairs. So now how does one automatically exchange GBP to BRL? XRP ledger has a feature called auto bridging. Okay, what it does, it takes the order book of GBP XRP, it takes the order book of XRP BRL, it combines both of them, okay, and then it adds to the normal GBP BRL. So if I want to exchange this in the back, or like on the blockchain will handle all these things. It will find the best possible rate. It will compare across all the open orders, okay, and then it will give me the best rate possible. Okay, even if I get, even if there are zero orders here, I can still exchange my GBP for BRL because it will compare across all the possible pairs on the XRP ledger. Okay, now let's move over to some hands-on. Which language is everyone comfortable in, Python or JavaScript? JavaScript. Okay, JavaScript. Okay. So yes, it has SDKs and a lot of, it even has an SDK for Rust. It's in development. Huh? Yes, PHP is also there. There are also HTTP and WebSocket APIs. Yeah. So JavaScript, right? Okay, so the first thing we will do is we will install the SDK. It is XRPL, PMI XRPL. Okay, it's done. This is the reference for the XRPL JS library, right? These are all the functions. Okay. Now there are different kinds of chains. Okay, you cannot like directly go on the mainnet XRP ledger and like, hey, okay, if I want to do a build an application, I will not directly build it on the mainnet. I will build it as a proof of concept. So on a test chain, okay, where I don't have to use my real money. Okay. So a testnet is, you can say, a fork, a one-to-one clone of the whole blockchain, but you don't have to use real money there. So you can switch to testnet, as you can see, and you can get unlimited XRP here because it has no value. So yeah, if you get 1,000 XRP, don't get happy. It does not have a value here. Okay, so the first thing is that we have to generate a wallet. Now, how do we generate a wallet on that? First of all, public servers. The other good thing about XRPL is that it has public endpoints. For example, the other day on Solana, I was building an application. I was trying to find a public RPC endpoint. I don't know if there are any good ones, but I did not find any. I had to go and use a third party service and get an RPC endpoint. But on XRPL, you have free RPC endpoints. What are RPC endpoints? They are basically URLs which are used to connect and communicate with the blockchain itself, right? So there are WebSockets, there are JSON RPCs. Okay, now we have one for testnet. Right? Let's use the testnet one. Okay, so we import the client, import wallet. Okay, we create a new client. We use the WebSocket. We are using a WebSocket here. So we use a WebSocket URL. We are on the testnet and we connect, and then we make a wallet. Another quick thing, you will have to do npm init. Okay, you will have to change the type to module. Now, as you can see, what we did was we generated a new wallet. Here we can see the public key, the private key, the seed, and the classic address. All addresses on XRPL start with an R. Okay. Now, what is the seed? This is nothing but the private key. Okay, so you can either use a private key or you can either use a seed. I generally like to use seed. Now, once you have some, once you have okay, yeah. Once you have the seed, you can then fund your wallet with some testnet XRP. Let's say I fund my wallet with 1,000 XRP. Okay, we need a host actually for that. Um, okay, we need to go to this website to get some test XRP. It is bithomp.com. We need to copy our address, the classic address. Okay, you can go to the faucet. Actually, my internet is a bit slow, but generally it's a lot faster to connect. Yeah, as we saw, we got 100 XRP from the faucet, right? Now, what is an address? An address is basically your own identity on the blockchain. Okay, it an address is what you use to transact with other people on the blockchain, right? Without an address, you cannot do anything on the blockchain, right? So yeah, so now we have some XRP. Now let's say I want to send it to someone, okay? Take this address, for example. Now, how to send a payment, okay? Now we have to first prepare it. Okay, so how to send a transaction? It's just like sending a request to an API with a JSON body, right? What is it? Transaction type. What is the transaction type? It's a payment. What is the account? So like who is sending the payment? So that is wallet.address, the wallet which we just created, right? What is the amount? Now what is XRP2 drops? In the blockchain, we can't use directly 1, 2, 3 XRP, right? One XRP is somewhere like 1 billionth drop. Okay, what do I mean by that? So if you want to send one XRP, you cannot just say blockchain like direct one. Okay, what it will do is it will instead send 0.001 XRP. Why? Because that's how it is denoted in the core blockchain thing. So when I say 1 XRP, the amount it will actually do, it will actually send to the blockchain is 1, 2, 3, 4, 5, 6. This is how much it will send to the blockchain, because this much equals to 1 XRP in the blockchain, right? So this is like, yeah, it uses fractional part in its blockchain. Now that is the amount, and that's why here we use XRP2 drops. So this is 1 XRP. It will automatically convert it to the drops, the native thing currency which is used inside the blockchain, inside the code. Okay, so that is the amount, and we use the function to convert the XRP into drops. This is the destination address where the XRP will go. Here we autofill. What does autofill mean? Okay, so it will add other fields to the transactions. These are not the only fields which we need. We need other fields like fee. What is the fee of this transaction, right? What is the sequence? Okay, now sequence, what does sequence mean? So XRP ledger, as we discussed further, it is atomic, right? So if I send one transaction, it will have a unique number attached to it. Let's say 1000. My next transaction will have +1, 1001 attached to it. Now that number is known as a sequence number, right? So what this autofill does, it will fetch my current sequence number. It will place it here, okay? And yeah, and then it will send to the blockchain. Now, the second thing we do is sign. What is sign? We basically encrypt this whole JSON with our private key, right? So nobody can decrypt and change the transaction. So what we send to the blockchain is actually a hash. We don't directly send the JSON. Okay. High level, yes, we send the JSON, but low level inside, it is actually hashing this whole transaction with our private key. And then it goes to the blockchain. It verifies with the consensus algorithm. And then, yeah, here, submit and wait. After we have signed this, okay, we can do this offline. So like, let's say I can sign a transaction, I can give the hash to anyone else, and they can submit it on my behalf as well because I signed it, right? So on this part, we need to be connected to the internet because we are submitting the transaction hash to the blockchain itself. Okay, and then we log the transaction. Mirror. Okay. There's actually another function for this. Actually, I'm more used to the Python library. Yeah.
I think, would it be in the payment JSON, the account?
No. It's there. It's in the autofill actually.
No, I mean like, it is like account is get the way.
No, that's fine. Actually, it is sending. What it's doing is right now it's sending an account info request to get our sequence number. Okay, and that's why it's failing here. Okay, give me 1 second. I have examples. Okay, perfect. So this is the hash, okay, with which we signed. Okay, so as you can see, this is the signed transaction log. Okay, and after we submit it to the ledger, okay, this is a response. So it has stuff like accepted, yes, applied, broadcasted, test success. Okay, and we can actually check this transaction, the account, for example, which sent the payment, the amount. Okay, as you can see, it is 10 because uh, yeah, we put 10, that's why it's 10. If we go to, we can check this on an explorer. If we just take the hash, we can copy it. We can go to bithomp, we can go to test.bithomp.com. We can just put the transaction hash here, and it will show us in a nice way, okay, of the transaction. Yeah, see, it's 0.001, because again, if we give direct value, it will be in fractions. That's why we have to use XRP to drops function. Okay, and you can see the raw value here, the whole transaction. So this, all this data, it is stored in the blockchain. What you see here, everything is in the blockchain. Okay, and this is another feature of the blockchain. It started in 2012. So all the data since 2012 is available. So you can go all the way back till 2012 and you can fetch the balances of users. Okay, so everything is on chain. The charts and everything which you see on the platforms of XRPL, they are data which is fetched from the blockchain directly. Okay, because it stores the history. So yeah, this is how you send a payment. And yeah, that is drops. That is not XRP. So like fee 12 is like 0.0001. Yeah. Yeah, because that is the standard. If I, for example, if I send XRP to drops, for example, if I send one XRP,
Okay, it is a steady.
yes, it's a steady fee. As you can see, I sent one XRP, but the fee is still 12 drops, 0.0001 XRP. Okay, so no matter how big of a payment you send, the fee will still be the same. Okay, for example, in other networks like Bitcoin or somewhere like, yeah, the more you send, the more fees it is. No, it's not like that here. It's super streamlined. Okay, we can see everything, for example, the time, the source, and as you can see, here's the sequence, right? This is my account sequence. If you check my previous transactions, its sequence will be 4263303, right? The sequence increases one by one. Okay, so yeah, that's the sequence. This is the, and then there's other data like in what ledger, okay, it went in, and at what ledger it was validated. It's not like if I submit a transaction at a particular block, it will get validated then and then. No, it might be congested and it might get pushed to the next block and it might get validated there. Okay, this is all the data, metadata. Okay, so like which account XRP got debited, which account XRP got credited, whatever happened during that transaction. So you can literally parse this and you can get the data of the balance changes. Okay, so yeah. So now,
Balance of the receiver's account.
yes, everything is public. But you can create just another address, like you can create 10 different addresses, right? So yeah, like it's anonymous as well. So nobody knows. Yeah. And the other thing is like, even if you create an address, it's not like anyone is going to know. For example, I just created this address. They're not going to know it belongs to me, right? So yeah, so it's pretty anonymous. That's why it's also used a lot for illegal stuff, okay? Because it's anonymous. You can literally make an address in 1 second. You can send a transaction in 3 seconds. Then you can also delete this address, right? So yeah, you can dispose it off. The other the other thing about the XRP ledger is, if you create, for example, a wallet on another chain like Ethereum, okay, or Solana, just create a wallet. Don't do anything. Okay. After one day, you will see you have 100 different types of NFTs and coins in your wallet. Okay, because scammers send you those scam coins and NFTs in your wallet, because if you click on any of them, you click on a link, you get hacked. Okay, on XRPL, if you want to do transactions on the network, you cannot just like like create an address and directly start doing transactions. No, there is a reserve. Okay, so what do I mean by reserve is, currently the reserve is 1 XRP. So if I want to start sending transactions, I need a minimum of 1 XRP in my wallet, which will be locked up. I cannot use it. Okay, so I cannot use that 1 XRP. It will stay there in my account. I will get it back if I delete my account, but it won't be usable. So if I need to make a transaction of 100 XRP and I want to create a new wallet, so I will need to create a new wallet. I will need to fund it with 101 XRP, because 1 XRP will be locked up. If I don't have, if I let's say I have 0 XRP balance, I don't have a reserve, then nobody can send anything to me, nor I can send anything to anyone else, right? So this is, so scammers cannot just come and like make new accounts and then start sending everything to people. They need to lock up some amount of fund. Okay, and even for all the other objects, NFTs, fungible tokens. Okay, if you want to hold them, you need to have some XRP on reserve. Like only activation is 1 XRP. This is testnet, that's why it's 10 XRP. But on the mainnet right now, it's 1 XRP, because XRP is like $3 right now. So 1 XRP is locked up. And if I want to hold NFTs, it is 0.02 XRP per 32 NFTs. So 0.02 XRP will be locked for every 32 NFTs I have, and 0.02 XRP will be locked for all other kinds of objects like checks, payments, etc. Okay, but once I sell my NFTs, if I don't have any NFTs, I will get the 0.02 XRP back. Okay, so that is the reserve functionality. So there is considerably a lot less spam on XRPL. There is still some spam, but it is really less compared to other chains, because I have made wallets on other chains, and yeah, I have like 10,000 NFTs on there because people just keep sending it, right? So that's one of the other features. Some people don't like it because you have to put some money on the side before you start it. And XRP, before the reserve was 10 XRP, and it was a lot because XRP's price went up to $3. It was 50 cents. So when it was 50 cents, 10 XRP is like $5 or something. And in order to lower the reserves, there is also like all the validators have to vote in that, okay, yeah, lower the reserves, right? And that also takes some time. But yeah, currently we got reserve as 0.01. You can check it on platform. As you can see, here's the base fees, reserve increments. Reserve increments is so reserve increment is how much XRP will you will have to put as a reserve for every object which you have on your account. Okay, for example, NFTs, per 32 NFTs, it is 0.2 XRP. Per currency which you hold, it is 0.2 XRP. Okay, now what are these? These are different values which were voted by different validators, but the majority is 0.2, that is 60%. That's why the reserve is 0.2. So whatever the majority of the validators vote, that will be the reserve. Okay. um, the base fees. For example, if we sent a transaction, it was 0.001, because that is the highest voted by the validators. So that fee will be used. If more than 50% of the validators say that, hey, the fee should be 0.002, right? So that will be the fee per transaction. So yeah. So now screen share बंद થઈ ગયો. Huh? No, it's okay. I'm just about to end now. It's okay. It's okay. I'm about to end now, anyways. Yeah. Need the remote. Ah, done. Yes. Okay, so now what can be the possible use cases? Well, I've been working with a project recently which are building RWAs. Okay, what are RWAs? They are basically fractional assets. So let's say if I have a real estate building, okay, and I want to allow other people, like let's say common people, to also invest in it. But of course, a common man cannot just go and buy a whole building, right? So they can buy fractions of it. Okay, I can issue a coin which represents the ownership of the whole building. I can sell it to people. Okay, they and yeah, so let's say if someone from here bought that coin, okay, which denotes the ownership of that assets, they can get the dividends, like whatever rent comes in, it will be distributed across the holders. Okay, so that is a really good use case. Then there are NFTs. There are also DIDs, decentralized identities, okay, on the XRP ledger that can be used. There are AMMs for liquidity pools, okay, rewards, and there are NFTs. Of course, NFTs also have a lot of use cases. You can, let's say, if you have a product which you only want a particular group of people to access, so like they can buy the NFTs and they will get access to your platform. Okay, so yeah, it's like when I started out on the XRP ledger, my first use case was connecting Discord bots to the ledger, right? So you can interact with a Discord bot. Okay, you can sign in with your XRP wallet on the Discord bot. It will record your address, it will record your balance, everything to a spreadsheet, right? Same goes with so as you saw, it's an API. You can connect it to any app. You can connect it to Telegram. You can connect it to Google Sheets. Like endless possibilities, because it's as easy as connecting to a normal API endpoint, right? So yeah, that's XRP ledger. If you have any questions, then yeah.
So why not just use testnet?
Then okay, testnet for what? Give me an
So if I'm, let's say, if I'm making an internal project,
yeah, for
let's
internal
say
use testnet.
if I'm working on a Git project and I want to just validate, I'm making a personal accountability bot for myself. And let's say if I'm saying that I have completed this feature, if I validate, then there's a movement. Doesn't make sense.
Testnet, but testnet is temporary. It resets every few months, so you won't have historical data.
So then second question would be, what if I want, like, say, Ankit and Archit, they want to validate my feature that I have built. I am falsy about me. मुझे तो
So like if you coded a new amendment or a feature to be merged.
I don't want Ankit or Archit to know XRD or blockchain or whatever. I just want to build this feature and I want to make it validated.
So what you can do, you can make functions. Okay, for example, send payment. Now, of course, when they will see the function, they will get to know, yeah, this is sending a payment. So what they can do, they can verify the flow, the logic on a high level, right? Of course, they cannot. And if they want to deep dive, then also they can just look at the code. So like what you mean is, if you code something on the ledger, and if you want them to validate it, that is this code good enough or not?
Yes, I mean, like, what if they sign up and what if I create account for them?
On where, like
Any API
On the blockchain, new account for them.
I mean, like, so general cases that I make a backup,
Mhm.
right? People will authenticate. With authentication, I make an account for them,
Yes.
and then it is getting validated.
Then you can use DID. So let's say if he signs up on your platform, okay, on the back end, you create a new address for him, okay, which belongs to him. Okay, then you can attach a decentralized ID to it. And yeah, so that way you can classify it. For example, the RWA example I gave, on that platform, you sign in as normal, like email and password. But once you are a user on there, they create a blockchain address for you, and then they store it. Like they don't store the private key. In that case, they use there's a third party entity which controls the address. Okay, so they don't control the secret keys of, so like of their users. Okay, there is a different entity specially made for this with all the rules and compatibility stuff. Okay, so they just communicate with that entity. For example, if I'm the user, let's use TL draw. So if I'm the user here, okay, and this is the platform where I'm signing up, this is the third party which stores the address and the secret keys. Okay, so there is a company called Palisade Custodial. Yes, it's called Custodial Wallets. There is a company called Palisade which is doing it. Now this is the platform. Okay, let's say, and this is me. So what I do is I'm not a blockchain user, for example. Okay, I'm just a normal guy. I go here, I sign up. Once I sign up, they send a request to Palisade that, hey, create an address for this particular guy. Now Palisade creates an address, it sends back to the platform. Okay, and then the platform gives me the address only, because Palisade doesn't give this platform the secret key. Okay, it keeps the secret key with themselves because they have the permission to operate like that. This company does not have the permission. Okay, so and then they give me the address if I want to see it. But for a high level user, they generally don't want to see an address, right? They just want to operate. So let's say if I buy a property, okay, yes, okay, so as a normal, like how it will be, I will actually show you. Yeah, so this is what they will see, but this everything is on blockchain, right? I can just click buy. You don't see blockchain anywhere, you don't see XRP anywhere, but in the backend it is being used. Okay, so I can just click buy. It will place an order on the DEX for me. It will exchange the tokens and it will give the token in my account, and this front end will display it. Okay, so yeah, that's how you can build around it. That's one way. You can also store the private keys. It depends on what country you are operating from, what company, what country your company is operating from. So yeah, the only problem with this approach is this platform becomes a little slow, of course, because you don't directly talk to the blockchain. You have to talk to a third entity. So yeah, that's the thing.
This question last
Yeah,
time.
yeah.
So about escrow, we can
About
do the time escrow. So if we use escrow
escrow,
for
yeah.
XRP, we can do the time based, but how can we do the event based?
Event based now, actually nobody uses event based because it's kind of cumbersome. When I have to be honest, personally, I have not read about it a lot, because event based, as far as I have known, it's basically if some person signs it. Okay, but 99% of the times time based escrows are used here, because again there are no smart contracts, so there are not robust events, right? Events in the sense, you can say a particular ledger, a block gets validated, then it goes out. Okay, or a particular event on the blockchain happens, right? So that way you can configure it, but it does not have a lot of robustness. That's why 99% of the time based escrows are used. Even Ripple has like billions of XRP with them. There is 100 billion XRP issued, but only 55 billion is in circulation, because the rest is locked in an escrow by Ripple. They unlock some million or billion amount of XRP every month. Okay, it's an escrow, so it's on the chain. You can go and verify it. And every month, once the XRP is unlocked, they sell some amount of it to the circulation, and they again re-escrow the other part back. Okay, so yeah, so that's one of the use cases of escrows. Okay. Any other questions? No. Okay. Yes. Thank you. I forgot to show, but I also have a template on XRPL where it's basically a Next.js project which has all the there are three major wallets on XRPL. So that template is a startup material. So like you can just clone it and you will have all the three wallet connections to go. So yeah, you won't have, because that's the first thing which gets a lot of developers stuck. So wait, how do I integrate a particular wallet? For example, we used Gem wallet in the demo. Okay, it open. So most of the developers are like, how do I integrate it, right? So I already have a template for it. If you want, just let me know. Okay, I will give it to you. So you can just start directly. You won't have to care about wallet connections. Okay, wallet connections will be built in that template. Yes.